Hi everybody, thank you Mary. My name's Graham. I work at a digital agency based up in Oxford called Incuna. We make websites and apps for the healthcare and pharmaceutical industries. So I'm going to tell you today quickly about a tool called Docker, which we're using to virtualize our development environments. So I'm not going to really go into much technical detail, but I'm going to sort of tell you the story of what led us to using this, why we chose to use Docker to sort of solve the problems we were having, and how it's been working out for us. So firstly, sort of what led us to use this tool. So to help sort of illustrate this point, I'm going to share a few scenarios with you. Maybe some of you might find some of these familiar. So scenario number one is working on the old project. So you get a call from a client or management or someone in your organization who wants an update to an old project no one's worked on for a while. You know the code changes are probably reasonably small. It probably won't take very long to actually do them. So you check out the project from your source code repository, follow all the setup instructions to get it running, try to start to run the project, but the project doesn't run. Why does the project not run? Last time you tried to run it was fine. Turns out something has, so you've had some bit of software that's been upgraded in your machine, you maybe had some OS patches, something is different since the last time you ran it, and the project doesn't run. And that's really annoying if all you want to do is make some really small, simple code changes. It's blocking you from getting on with the work you want to do. Scenario number two, you've got a new member of staff, just started at your organization, bright young new member of staff, or maybe you've got a freelancer working with you for a few days and you want to get them up and running really quickly into some actual coding. So you give them the project, they sort of pull the project, follow all the setup instructions, install all the software and configure their system in the way that the instructions say. And then they try to run the project, but the project doesn't run. Why does the project not run? Turns out maybe they're a new member of staff, they've got a new machine, no one else in the organization is using, has some sort of different setup, maybe because they're unfamiliar with your organization's systems yet, they haven't followed a certain step in the install guide, and so you end up sort of helping them set the environment up, and that again takes time away from doing the actual code that you want them to get into. So scenario number three, the missing documentation. So you've got a team happily working away on a project. They're all working fine. One developer realizes that the next sort of feature needs a new bit of software adding. So say you're working on a web project, you need to add memcached to the sort of stack for that project. That developer writes the code that's required by that new bit of software, installs a bit of software on their machine, but they forget to put it in the documentation, the setup guide. They should be doing this, but everybody makes mistakes and sometimes forgets things. That developer is then unavailable for a few days, say they're ill or goes on holiday or something. The next person to try and run the project can't run the project. Why can they not do this? Because they then spend sort of several hours trying to look back through the code and figure out what that bit of software was that was needed. Scenario number four. There's different people on different OSs and different machines. So the same situation as before, you've got a team happily working away on a project. The same developer realizes that they need a new bit of software for the project, adds it in. This time they're a really good developer. They add it to the setup guide and all the install instructions, but that developer is using Linux. The next day, another developer tries to work on the project. He's using Mac OS. And then they try and run the project, which they could previously run perfectly fine, but the project doesn't work. And why does the project not work? Turns out on macOS it has some different compile steps, so it has some different prerequisites, something else that you need to install. And again, you spend time trying to figure out that out before someone can actually get on with their work. So what do all these scenarios have in common? These are all problems that related to the environment and sort of setting up of the people's machines and project environments. These are all sort of scenarios that we faced at some time or another and possibly maybe sound familiar to some of you. They're all problems that usually end up requiring someone senior on the team who understands how the whole sort of project goes together, the stack, and how all the sort of bits of software interact, trying to fix, which means these problems are usually costly and can often be repetitive. You sort of end up fixing them on different people's machines. As we heard earlier, sort of good developers are lazy developers. We love to automate things. There must be sort of a better way to do this. So these are the sort of problems we were looking at. I sort of identified what are the key characteristics of a solution that would enable us to sort of get round and fix these problems. And these are the sort of 4 things that we identified we wanted to be able to do to keep having these problems. Number 1, we want to be able to store some description of the project environment along with the project source code, which means that if any developer adds a new bit of code that requires a new bit of software, those 2 things are coupled together and they can't add one without the other, and you never get the 2 going out of sync. We want to make everyone use the same environment, so if a developer on one OS adds a bit of software that's needed for the project, developers on other machines will be able to use that same bit of software. We want it to be a reproducible system, so if someone gets a new machine, we can just sort of start the project up from scratch without having to install a lot of stuff. And we want that ultimately to be automated. So we were sort of looking at what could we build, what sort of system could we get that would fulfill these requirements. And the sort of first things we looked at were a custom build scripts using sort of bash scripts that would install all the software that you needed for the project. But that was sort of quickly discarded because we'd have to maintain that ourselves. We'd have to maintain, for it to be useful, we'd have to maintain documentation. So then we thought, what else is already out there? And where a lot of people are solving these problems is using virtual machines, a system like VirtualBox or Vagrant, where Vagrant particularly, you can store a Vagrant file with your project, and that will sort of define all the build steps that are needed to create the virtual machine that will run your project. But for us, the disadvantages of using a system like that were, apart from the sort of run speed, because when you're using a virtual machine, obviously you're virtualizing all the hardware, stuff runs more slowly than it will natively, but also the disk-based requirements. So as we're a sort of a digital agency, we have quite a high throughput of projects. So typically, sort of in the last 2 weeks, I could have been working on 10 to 15 projects, and if each of these required a sort of several gigabyte Linux image to download, sort of rapidly filling up your disk drive on your machine. So that sort of led us to look at a more recent tool called Docker. And Docker shares a lot of the sort of conceptual ideas with virtual machines. The way I like to just sort of describe it is a VM is virtualizing the entire machine, including the hardware, whereas Docker is sort of virtualizing just the OS part, which means it has a lot of speed improvements over something like VirtualBox. But also, if you go further and embrace the sort of Docker way, you're encouraged to virtualize all the individual services and components of your application. This means if you do this, you can sort of gain a lot of reusability between different parts of your application. So if we have a lot of projects running, we can reuse components between those 2. So we're now using a system based on Docker and Docker Compose. And Docker Compose is a tool that lets you define these separate virtualized services within your project as a YAML file. So as an example, sort of in a typical web project we might be running, we'd need a developer to be able to work on it. They'd have to install Python on their machine to run the CMS that website would use. They'd need to install Postgres as the database backend for that site. And they'd probably also need to install Node.js as part of our sort of front-end asset building system to generate sort of sprites, image sprites and that sort of thing. So with Docker Compose, we can have a single Docker Compose YAML file in every project that we have. And there's a section in that YAML file for each of these services that describes all the build steps needed from a basic Linux box and all the software that's needed to install and then run these applications. And then we can sort of share those. So if we have a common Python config that's used by many of our projects, we can package that up as a disk image and share that between all the different projects. And this means that once a developer has got Docker and Docker Compose installed on their computer, all they need to do is run this single line at the bottom, Docker Compose up project, after they've checked out the project. They just run that one line, and it will automatically build the system. And they'll have a website sort of up and running within 10 minutes or so. And then they can then sort of get straight on with coding without sort of having to worry about the environment. So this is the sort of system we're using. We've been using this for about 8 months or so, sort of iterating on and improving it as we go. And how's it sort of been working out for us? So 2 ways, I would say. The first thing is the time savings. Certainly as lead developers, sort of senior developers and or just the regular developers sort of getting things running. It's been saving us a lot of time. As an example, we recently had a new member of staff start with us a few weeks ago, and she was able to get what's probably quite a complicated web project up and running and sort of editing code and writing CSS within the space of an hour, whereas previously that would have probably taken half a day to a day of setup time, following instructions, setting up all the software required on her machine to run that project, also with probably extra help from somebody else. So definitely time savings, and also sort of increasing the bus factor on our projects, so we're no longer reliant on the one person who knows how the whole project goes together, how the stack works, how all the different parts interoperate. Firstly, any developer can run that very easily, but they can also look at the sort of self-documenting nature of the Docker and Docker Compose files in the projects, which list all the build steps needed and all the software that's required to run each project. So that's sort of, everything's been working out quite well for us. So where would we like to go with this in the future? There's a few issues around macOS on Docker. It doesn't run natively on macOS, so you need to run it within a virtualized version of Linux, which you run Docker inside. And that, by and large, works pretty well, but it does have problems when you're doing anything requiring intensive disk read writes, which includes our sort of front-end build system. So there's definitely improvements we'd like to make there. Also, the tool that most people are using, or the use case that most people are using Docker for is actually using it in production. So that's something we'd sort of like to look into in the future, is making our sort of development environments mirror the actual production servers. And apart from being able to then spot problems much earlier than you would have otherwise, what that means is you can then take advantage of several of the sort of cloud hosting providers who will take the build scripts that we've already built for building our environments and then deploy servers directly from those. So in summary, this has been really successful for us. I definitely encourage, if anyone else has been facing the same sort of issues as I was describing earlier, to look into a system like this for virtualizing your sort of development environments and storing your environment configuration along with your projects. And if anyone out there has got any experience with Docker, I'd love to talk to you from a technical point of view, see if you've got any suggestions on how we can improve things. So catch me in the breaks or at the after party. Thank you.